The following two lessons focus on symmetry, which originates from both Greek and Latin to mean the same measure. Firstly, what do you see in this image? You may see two humans, or a dog, or an elephant, or a bear, or if you're a mathematician, a single line of symmetry down the middle. This is an example of a Rorschach test, or ink blot test, invented by the Swiss doctor Hermann Rorschach in 1921 to see how his patients interpreted ambiguous designs to assess their personalities. This technique of investigating personalities was first documented by Leonardo da Vinci in the late 1400s. You may also recognise the design on the mask of the DC Comics Watchmen character of the same name. Pause the video now to try to read about Leonardo da Vinci and how he used mirror writing. If you had difficulties, pause the video after it's been reflected. This is a snowflake. You may notice it is symmetrical in a few ways. Why is it symmetrical? How do they form? Why is it so elaborate? By studying symmetry, the mysteries of nature can be unveiled. Knowing about symmetry can help scientists predict particles before they're discovered. This is an early photograph showing an electron with a negative charge, and its mirror particle, a positron, with a positive charge. Notice the symmetry in their spirals. By studying symmetry, further particles are predicted and then discovered. For example, the Higgs boson was predicted way before it was discovered in the LHC in Switzerland. Symmetry can help us to understand how the universe works. To understand symmetry, let's investigate the lines of symmetry of an equilateral triangle. Take a moment to work out how many it has. The answer is 3, and they can be drawn like this. By drawing a line from a vertex to the opposite edge, you can see it's the same on both sides. The same can be done from all 3 vertices, so it has 3 lines of symmetry. Here is the second. Here is the third. Pause the video at this point to try to write down how many lines of symmetry these shapes have. The pentagon is regular, and it has 5. Here is an example of one of them. The no entry sign has 2, 1 and 2. The square has 4, 1, 2, 3, 4. The oblong, or rectangle that isn't square, has just 2, 1, 2. And the parallelogram has none. Spend a moment to consider how many lines of symmetry the circle has. Interestingly, it has infinitely many, because you can draw any line that goes through the centre, and it will be the same on both sides. The next video considers rotational symmetry. After watching that, there are some exercises to try.